help power DART, the double asteroid redirection test, as it makes its way to the Didymos asteroid system. ROSA, proven on the space station, and powering its way to the moon and beyond our planet's reach.
Ready to deploy on its own once that final bulk was released. The deployment beginning at 12:45 p.m. Central.
The satellite will eventually be powered only by sunlight hitting a mylar sail. The spacecraft was not developed by NASA, but a non-profit group of private citizens. The planetary mission is made possible by a new generation of small, relatively inexpensive spacecraft called CubeSat, making space exploration affordable to universities and businesses.
Last year, about 100
spacecraft can be propelled simply by capturing light,
which has never been done.
Of distant and mysterious places. John Blackstone.
Getting any power from the sun, but that was a really interesting time for the team during launch, is knowing that we had to make sure the arrays were deployed to get sun, or the spacecraft would just have died. Getting any power from the sun, but that was a really interesting time for the team during launch, is knowing that we had to make sure the arrays were deployed to get sun, or the spacecraft would just have died.
Where communication satellites are located. The solar array is Webb's first deployment. When completed, all of Webb's electrical power needs are satisfied by the solar array for the remainder of the mission.
Mid-course corrections, the Webb telescope passes the orbit of the moon.
Webb's initial transformation is the deployment of the sun shield pallets. Aft flap deploys. This is key to managing momentum buildup and fuel consumption. This structure helps to balance the pressure from the sun's light on the Webb telescope around its center of mass. It is now time to tension the sun shield membranes, each thinner than a human hair, pulling each of the uniquely sized and shaped layers to their optimal position. When deployed, the sun shield allows the telescope to cool to 385 degrees Fahrenheit below zero, cold enough to liquefy air, while the layer closest to the sun is almost 190 degrees Fahrenheit above zero, nearly the boiling point of water. Instruments to radiate their waste heat directly into space and away from the telescope. Disposing of excess heat is crucial to the mission, signals to be collected from the cosmos. The cord fold wings deploy and latch in place, completing the major deployments of the largest telescope in space. As the Webb telescope continues out to its operational orbit around the Sun Earth L2, the observatory continues to cool down.
With the NASA Marshall Space Flight Center with no bearings or hinges, friction, because it looks really crazy, but it has a very important precision motion. And here is that same device but shown as in a thruster. So there's the thruster that's positioning a satellite.
Scientists and engineers are rethinking the design of spacecraft, satellites, and space systems by drawing inspiration from the art of folding, pushing the boundaries of efficiency, versatility, and performance. Space exploration presents its own set of challenges to otherwise perfectly suitable Earth-bound technology. One huge issue is the limited storage capacity of rockets. Luckily, Origami offers a solution, enabling the development of lightweight and compact structures that can be folded for launch, conserving valuable payload space. Once in orbit, these structures can unfurl themselves, revealing their full potential and transforming them into functional
permanently through a series of launches and spacewalks. The arrays augment the existing power supply and restore power to previous levels when the original arrays were installed. ROSA technology is also an important part of future exploration.
This folding technique is seen with Starshade. Developed at NASA's Jet Propulsion Laboratory, Starshade is a 118-foot screen that will be folded down to a mere 8 feet for launch. Once in space, it will unfurl to help space telescopes see better by blocking interfering light from neighboring stars. Even the mirrors of the James Webb Space Telescope were folded to fit inside the rocket that launched it. Using
as a design for satellite solar arrays, increasing compactness for launch, and reliability in deployment. A new area for origami research?
Increasing compactness for launch and reliability in deployment.
Why is it that this ancient art of paper folding is so useful for modern engineering? Origami, literally folding paper, dates back at least 400 years in Japan, but the number of designs was limited.
There were only a handful of patterns, maybe 100, 200 total.
Being used for high-tech and sci-fi-like technology developments. Everything from spacecrafts to pill-sized robots we ingest. Can origami exploration agency launched the Icarus. This spacecraft used a solar sail that propelled it from Earth to about 80,000 kilometers away from Venus. A solar sail works like a boat sail, but instead of wind, light particles are bouncing off of the sail in space, moving travel to other solar systems possibly within 100 years, which would take tens of thousands of years with today's chemical rockets, and tested 2 generations of solar sails. Light Sail 2 uses materials that are thinner than a human hair. The thin material, along with origami folding methods, allows for a larger solar sail to be packed and launched into space. To really see space origami in action, then we need to have a look hand up to block the sun. A star shade acts like your hand. It will move in between the stars and the telescope, allowing faint planets to be imaged. This lets space telescopes study other planets and see if there are other Earth-like habitable planets, where life might be possible. These star shades would have to be large. In space, the star shade would unfold to a diameter of about 85 feet. So NASA is working on origami techniques to fold and allow them to fit into sheets of origami robots, and they will transform and perform any task.
And make them out of thin materials, and wherever you can make them out of thin materials, you can use origami to fit them in these rockets.
Many space projects have used the folding principles of origami. The solar array wings on the ISS use a Z folding pattern, and the Mars Phoenix lander used a fan-folding solar array called the Ultraflex. Is where the star shade comes in, to help block that bright light to better help astronomers learn more about these mysterious planets
that flies in front of a space telescope and blocks out that starlight so you can image that really faint planet right next to it.
Sounds easy enough, but origami has been practiced on Earth for years, and scientists will continue to draw inspiration from it to help package big space structures more efficiently, from solar sails that use sunlight for propulsion to sunshades for telescopes like Gaia and the James Webb once it launches in 2019.
By stowing it compactly during launch and then opening it up once we're in space. The spacecraft would be inside a rocket, like an Atlas V rocket, and the solar array would wrap around the outside of the spacecraft. It would be all folded up compactly and then launched into space.
The station's robotic arm unfurled the first ROSA, or rolled-out solar array, in 2017, testing a new and unique concept. Instead of a rigid solar panel, ROSA was crafted from a composite carbon fiber, containing an array of solar cells that can be deployed and retracted similar to a tape measure, using stored strain energy of the material. ROSA was also lightweight and